Amsterdam, and we do these kind of events, sometimes workshops which are more hands-on, sometimes career-based sessions, sometimes other kinds of boot camps. But the idea is to help the community by bridging the gender gap through skilling and upskilling. And we want to help anyone who's looking with career switches, with advancing their careers through Python. And today's event is being co-hosted with Python in London, and Rory is one of the co-organizers. So maybe he can do a quick intro of Python in London.
Thanks, Bhumika. Yeah, as she just mentioned, I host Python London, which is anything to do with Python, really. We're obviously London-based, but over Zoom these days, and has been for a couple of years now. And it's just events to do with the language in general. So we've had speakers who are a couple of people who are CTOs and heads of engineering talking about Python, a couple of workshops, people new to the language, and just generally getting more information out there about the technology, helping people understand a bit more, and bringing people together, really.
Okay, thank you. And today's session is the second session of the Careers with Python series. And today we'll be looking at recruitment tips, data engineering, and educational sciences. And our first speaker will be Rory, who will talk about recruitment tips, and then to Carolina, and last speaker is Giel. He'll come back in a bit. And ground rules: please keep yourself muted during the presentations, and you can drop questions in the chat here. On YouTube, you can raise your hand. Feel free to interact, but not interrupt. And yeah, have a good session. We hope you learn a lot. And over to Rory now, and he will take over with the first session.
Great, thanks. Yeah, because of my technical issues, I'm not able to share my screen, unfortunately. But yeah, Bhumika, would you be able to put my presentation up on the screen, please?
Yes.
Thanks.
Can
Brilliant.
you now see my screen?
Yes.
Perfect.
Great. So yeah, obviously, welcome everyone. I'll be doing just a brief talk about the Python market in general. Hopefully, for anyone who's maybe more junior, introduction to it, but some insights into the industry, recruitment, and interview tips as well. So a bit of background into myself first. I'm a principal consultant at Oliver Bernard, about 5 years technical recruitment experience, and currently leading our Python and data engineering desks. So we recruit for anyone from graduate / junior level all the way up to heads of department and everything in between. Those companies there are a couple of businesses we've recruited for recently, but really industries include anything, in all honesty. Fintech, media, e-commerce, crypto is really popular now, energy, tech for good, anything else. Python is currently, or at least was the other week when I looked up recently, is the #1 language on Stack Overflow. So anyone looking for a job working with Python really does have a broad area that they can get involved in, and a wide-ranging pick of opportunities. Sorry. So yeah, can you move the next slide, please, Bhumika? Great, thanks. So Python market, as I mentioned, one of the advantages with Python is there's a lot of choice out there, and it can be applied in a variety of ways. Whenever I speak to junior developers or students, whatever they're really looking to get into within technology, I'd always recommend Python as a language to work with. It's a good building block for a lot of languages, and it in itself is one of the biggest languages on the market right now. So there's lots of opportunities for anyone looking for a job. There are 3 broad areas within the Python market. These do overlap quite a lot, and I know Python can be used in very different areas, but generally speaking, you have data engineering, software development or web API development, and machine learning / AI. I've listed some of the most popular tools and frameworks there that might be worth looking into for whatever area you're looking to get into. So in data, there's a couple of streaming things there, some databases to look at. For the web stuff, a couple of frameworks, microservices, and obviously some machine learning tools. Now, these aren't, I say, the only things to look at, but they are the most popular things on job specs these days. So if you had an area in any of these, then it is worth looking into. Cloud technology is quite interesting. Most companies these days will have dedicated DevOps teams, at least larger size companies, or cloud engineers who work directly on the platforms and do a lot of integration and deployment and that sort of thing. But having at least a working knowledge of cloud technologies will help you stand out from the crowd. AWS is the most popular these days, but GCP and Azure are still widely used. It's worth noting as well that a lot of these skills are transferable. So, for instance, if you'd only ever worked with the Django framework and you like the look of a job that worked with Flask, most companies will allow you to work over and will help you do that. So, yeah, that just gives you a bit of an idea. Those salary levels in the bottom left, that's for the London market and an average. Obviously, location will change things, and industries will change things as well. You know, clearly investment banks and trading companies will pay a lot more, or maybe startups a lot less. But it's a useful level to have a look at. And between those levels as well, that doesn't mean years of experience moving up levels. It means how many areas can someone contribute to. So someone who's junior and mid-level will work alongside senior engineers, upskill themselves, work on specific things, and yeah, really, you know, get a lot of help with it. Someone who's senior or principal will be involved a lot more within architecture and design, as well as coding, and maybe even infrastructure and deployment as well. So that's worth thinking of as you move forward to your career. But yeah, how to find your company. Can we move to the next slide, please? Thanks. Yeah, so as I mentioned earlier, there's loads of different ways and loads of different companies that use Python. So how do you find the best company for you? Job boards and LinkedIn are great tools to use. You can search using location, salary, and keywords. So you can put in things like hybrid working, remote working, or whatever it might be. Referrals are really good to use as well. Speak to anyone you know in the industry about companies they've worked for or their current company, companies they've interviewed with. All can be really useful tools. Things like Glassdoor and websites like that as well can be quite useful. Would take those reviews with a pinch of salt sometimes, but if you see a general trend, they're definitely worth looking into. And recruiters as well, I believe, are quite an invaluable tool. Now, I know there are lots of stories about bad recruiters, and obviously there are bad recruiters out there. But if you work with somebody who knows their market, it can be a really good head start. We can offer you a range of opportunities at the same time, to give you an idea of the market, your worth, and what would suit you best. What can be really crucial, though, is learning a bit more around just a job spec or a website. You can find out which companies are more hybrid or remote focused, depending on what you're looking for, which companies really champion diversity, and actually have examples of doing that, rather than companies that just maybe stick it on a website but don't do a lot in that space. The makeup of companies' teams, whether they're really geared at helping junior engineers grow, that sort of thing. And it's worth remembering as well that recruiters only get paid once they help a candidate get a new job. So they are on your side when it comes to all of this. So if we go to the next slide, please. But yeah, so how to stand out. Once you've found a company that you think you like the look of, a role you'd like to apply for, it can be hard to get your CV or your profile in front of the hiring manager and one that looks good. Now, I visually put all these squares next to each other because I don't believe that any one is more important than the other. Things like education and degrees clearly can be very useful. They can be a sign of a strong candidate, and lots of companies favour them. But please don't worry if you don't hold a computer science degree, or if you're not from a maths or physics background, or if you don't come from traditional or mainstream education. Lots of companies don't worry about that. Again, a recruiter can point you in the right direction over which one's good or not. But yeah, there's no one way to get into the industry. Coding courses are a great way to upskill yourself, especially if you don't have a lot of commercial experience. They can be a great way to showcase your skills on your CV. With coding courses, they all offer something slightly different. Ultimately, they're all viewed the same, as in well, by companies, but some have got a much more of a community basis. Some are very structured. Some are more a massive information where you pick and choose what you want. So it's really up to you to see which one works best. Ones like Lewagon and Codecademy, I'll put these links in at the end, are very good sort of generalist ones. There's ones like Girls Who Code, Black Code Girls, and others that are obviously focused at individual groups, which can be very useful. But there's lots of tools out there from that side. Leads a bit onto personal projects as well. Please talk about personal projects in your profile. They can be a really good way of showcasing, again, your skills, but also your interest and enthusiasm for technology. It's a way to stand out. And again, especially if you don't have a lot of commercial experience, it's a great thing to talk about in interviews and showcase what you've done. GitHub and Stack Overflow are really good tools for this. I'll speak a bit more about them later as well. And meetups are a great tool. Whatever group you might be part of, be it PyLadies Amsterdam, Python London, and plenty of others as well. They're a chance to meet people in the industry, learn more about the market, and again, show your passion for technology. There's a Slack Python group that can be very useful, especially if anyone's looking at doing anything in their own time. It can be a really useful tool to speaking to other developers and getting information from them about how to maybe work with a specific tool, how to solve a problem, and that sort of thing. Yeah, can we go to the next slide, please? So the interview, this is obviously arguably the most daunting part of finding a new job is actually interviewing for it. Once you found a company that I look of and you're happy with how your profile is and how your CV stands out, you hopefully get invited to an interview. Now, I'm just going to try and give people a brief overview of interview processes and what to look out for and what companies are looking out for, which might be quite useful. So the first stage is almost always an introduction call. That can be either a phone call or a video call. What it will be is a chance for you to learn a bit more about the company and them to learn a bit more about you. So they'll speak about the specific role and the specific team you'd be joining. And they'll be looking to get a bit more background into yourself outside of your CV or profile. So they might ask questions such as, what was your role within a specific team? Or what tools did you use? Or if it's the first job you're going for within technology or Python, what personal projects have you looking at? That sort of thing. It's a 20-30 minute feeler from both sides, and it does give you the chance to basically see if it could be a good opportunity for you. And if you don't like the sound of it after that first call, then feel free to not move forward for the process. Moving on from that, some companies, but not all, will send out a technical test. This is normally a very simple task for you to have a look at. It'll take 1 to 2 hours, take home, so do it in your own time. Some of them are timed when you log on, but generally they'll just say it'll take 2 hours overall. If you get it back to us next week, then that would be great. I always like to stress here that it's not about producing clean, perfect code that we can deploy straight away. That's not what they're looking for. They're looking for how you approach a problem, documentation, and proof of testing protocols. This is where GitHub and Stack Overflow can be really useful because there's information on there about tech tests. You can do practice tests and you can ask for help with tests. So those are really useful. There'll always be some sort of technical interview, which may be the second or third round, depending on the company's process. It differs slightly, but there's either be a pair programming or screen share or a systems design / whiteboarding exercise. Again, similar to the tech test, they are aiming to test your approach to the problem rather than exactly what you produce. It's not meant to be, or it is very different even to day-to-day work. And it can be quite nerve-wracking and daunting. So they're not expecting things perfect. So think about how you communicate in this stage of the process, how you might ask for help if you're stuck on a problem. Everyone knows that Googling is an important part of being a coder. So if you don't know something, feel free to say to your interviewer, I'm not exactly sure what to do here. I think it's this. Can you give me a bit of help? That sort of thing is what they're really looking for. And then the final stage, generally a roundup of everything. It'll be focused more on the cultural side of things rather than the technical side. Hopefully by that point, that would have been assessed. So it's really a chance for you to ask any questions you might not have got throughout the process. And this can be anything from financials in terms of bonuses and stuff, but general packages, I guess more the life balance of the work life of the job. So things like parental leave, holidays, sick leave, mental health days, learning development, career progression, all that sort of stuff will be around on this final stage interview. So that's the time to ask them. Lots of companies have about us or values pages and things like that on their website. So, you know, they'll be talking around that. How do they fit in? And that sort of thing. So yeah, that's really the chance to get all the information you need, and see if it's a good opportunity for you. Hopefully then you receive the offer. And then obviously you have a choice between accepting, rejecting, or negotiating. This is where it's important to know your worth. I know there's a lot of issues, especially around gender pay gaps and minorities and things like that around around pay gaps. So it is hard to know exactly what you're worth. A recruiter can advise you, but you can look at other job postings online. You can speak to people within the industry and work it out, and be firm on that. If you feel like you're being under offered, there may be a specific reason. You know, it may be that they feel you lack skills in a certain area, so you come in at a different level, have a chance to upskill and then move up to that level. Sometimes companies just want to under offer to try and get away with it. Probably not companies you want to work for. So it's worth looking into all of that. Things like bonuses, shares, and packages come into it as well. I think it's really important, for me at least, to stress at this point that inclusivity around recruitment has thankfully really improved over the last couple of years. So even though this is a standard interview process that you're looking at here, companies will be able to tailor to individuals. Lots of people struggle or aren't confident in different areas of the process. So feel free to ask if you want that to change. Whether you ask your recruiter or if you're speaking to company directly, ask the company. You know, if you don't want to do a certain part because it makes you feel nervous or you don't feel like you're performing that well in it, let them know. Ultimately, a company that isn't flexible around disability, personal circumstances, neurodiversity, religious beliefs, whatever it might be, they're not flexible around those issues. They're probably not companies you want to work for. So don't be worried about asking to change interview processes. This is what the process is for, to work out if the company works for you. And if their interview process doesn't work for you, it's unlikely that the day-to-day role will work for you. So that's worth noting. But yeah, look, that's just quite a brief overview of the market and interview. Can you move to the next slide, please, Bhumika? Yeah, these are just some useful links for you to have a look at. We can send them out if needed as well. Slack, GitHub, and Stack Overflow, I'm sure everyone has already looked at, but they're there. Those are a couple of the coding courses that to look at. With Me is a community, and there's lots of ones similar to it out there. They actually focus on helping ex-military people and people with neurodiversity, help them to get jobs within technology. But there's many other tools out there like them, who are a community for people to help them gain a foothold into the market. PyLadies Amsterdam, I know, do a lot of work with female developers and help them as well. So those communities are useful. That's my LinkedIn there. If anyone has any questions about recruitment, industry, Python in general, interviews, please let me know. But does anyone have any questions now about any of that? Just got a question from Joe. Completed a Python course on Udemy. That's another good coding course, actually, Udemy. Yeah. And been coding in Python for just over a year. Any advice on what level I need to be at before applying for jobs? Also, I'm 37, not from a tech-based background. Will this count against me? Could you please speak on what sort of work-life balance you expect with a junior Python role and the type of work I would be undertaking? Yeah, good couple of questions there, Joe. First of all, as I say, Udemy is another one of these coding courses that I do think are quite strong. On what level you need to be at before applying? I mean, to be honest with you, companies generally take on people at any level. It depends on the type of company. Clearly, larger companies will be more set up to take on more junior developers, and hopefully they'll be able to place you in a team with more senior engineers to help you learn off. So I wouldn't say at any particular level. In terms of salary levels, if you're in the London market, probably 30 to 40,000 pounds a year would be a standard base salary. In terms of age, I don't think it should be a factor. I know in reality it is a factor for a lot of companies, but equally there's lots of companies that aren't. So it's worth looking at mission statements on companies' websites for the type of people they've hired in the past, and their commitment to bringing on people who might be slightly older than the average junior developer. So it may slightly limit your options, unfortunately, but it certainly isn't a huge factor these days, and companies are being a lot more flexible with it. Again, work-life balance, that changes from company to company. There's no reason why as a junior developer you need to take a job that's 10 hours a day, 5 days a week, plus out of contact hours. Most companies are really addressing work-life balance in terms of the in response to COVID and that sort of stuff. So flexible working, especially with people with families and things like that, has really grown. In terms of the type of work, it obviously depends on what type of company you're joining and what their tech stack is. But generally, as a junior Python developer, you will be looking at probably executing some very specific tickets. So you'll be tasked on a small part of the platform, working with an existing team of probably generally anywhere between 5 to maybe 20. Work on a small area of the platform and either looking to expand it, working on greenfields development, where you probably do a lot of work alongside a senior developer, where basically between the two of you, you'd be building new areas of the platform, or you'd be executing tickets with the supervision of a senior engineer. So I think anyone who's a junior, worth looking at the setup of teams more than anything, and how much they help junior developers grow from that side, how much mentoring they have, and if they have a specific training structure in place. I was a question. Hi there, accountant by trade, have a maths degree, currently working on getting a Python certification through an online data science learning website. How should I approach getting a job in machine learning once I get the certification? Similar to Joe, actually, to be honest with you. Looking for a company that actively hires junior developers and has hired juniors in the past and has a real strong training structure in place. For I think anyone at the junior level, that first stage interview is really important, to ask them about what do you have specifically that you can tell me about training and upskilling. It's all well and good a company on a spec saying they'll help people train, but understanding how they do that. So do they have dedicated learning and development days? Do you have a specific engineer that you're working alongside? In terms of getting a job in machine learning once you've got the certification, again, tools like JobSite and LinkedIn, all recruiters can point you in the right direction and see companies that have opening for junior engineers. Unfortunately, lots of companies are only interested in seniors at the moment, which can be frustrating because everyone needs to start somewhere. But mid to senior sized companies who have got a really good platform, an exciting product they're working on, and are growing that out, have the scope to bring in junior engineers. So those are the sorts of companies you should focus at. I think in reality, the smaller size startups and those sorts of companies aren't really going to have the bandwidth to bring on juniors. And then Catalina changed her career from laser scientist, sounds very interesting, to programmer. I've done some programs using Python and MATLAB. Could I ask for a junior position while I am studying machine learning? There are companies that will do that, whether that's an internship, which are generally paid these days. You don't get many unpaid internships, which I think is probably a good thing, in all honesty. But yes, lots of companies will do that, whether it's part-time work, whether it's in terms of a few hours a day or a couple of days a week, or whether it's actually something you can work alongside a specific degree if you were doing that. There are companies that do that. Again, that's where it's worth searching for part-time, a keyword you can put in, or things like that on job boards. I hope that answers those 3 questions, or if anyone's got any more. I'm not sure how we're doing for time as well.
We still have about 10 minutes, so cool. Feel free to drop in any questions. I also have one question. So typically I have a lot of trouble with negotiations of salary and sometimes also with flexible work-life balance. So how do I approach that or even begin that conversation?
Yeah, no, it's a really good question, and it is a very tough one, and I understand that, because if you don't, especially if you're new to the industry, but I think for anyone really, it's hard to see what the general market is like, because people really only know obviously their current salary or their expectations, and probably don't know what you're leveled at compared to the rest of the people in your company, let alone the rest of the industry. So it can be very tough. Looking online at job listings and that sort of thing, Glassdoors and those sorts of websites can be very useful. There's a real push in the industry to publish salary bandings on every single job spec, because I know how frustrating it is when you look at a job and there's nothing on there in terms, it just says competitive salary or things like that, which is useful. So worth looking at all of those and looking at the requirements within roles and seeing which boxes you might tick, and what type of role you might want to do, and looking at maybe, you know, up to 10 similar adverts, and seeing, right, this is the general salary level. And then it's about really being firm on that, and knowing what your worth is, and worth raising that from the start. I think the worst thing people can do is get all the way to the end of an interview process, and then at that point then try and start maybe negotiating. Well, obviously you negotiate at that point, but then try and start bringing up what they're looking for in terms of salaries, as you say, flexible working, be it well, whatever it might be, you know, part-time, flexible arrangements for childcare, or all that sort of stuff. That's worth raising right at the start. So that introduction call, which I mentioned a bit earlier, that's the time to say, you know, look, I like the sound of this opportunity. These are my salary expectations, but I'd be looking to do a 4-day work week, or be looking to do fully remote, or I'd be looking to leave at or finish at 3 p.m. on Wednesdays to pick up my child, or whatever it might be. Those are worth, raising right at the start of the process, and at least you know. And sometimes a company might say, well, we can't accommodate that. Well, at least you know after a 20 to 30-minute call. It's better than getting through an interview process, spending 2 weeks speaking to a company, endless hours. So yeah, raise it as soon as possible. Again, I understand it's hard to know exactly where to level yourself in terms of salary. So that is why it's worth looking at job listings online. You can check out Glassdoors. Google has a salary. I'll see if I can find a link to send over to people, because I can't remember off the top of my head. But Google have collated salaries from across the internet and given people a benchmarking on what to expect based on years of experience and specific technology skills. So that's worth looking at as well.
Okay, thank you. Any other questions for Rory? I also see one question in the YouTube chat. Do hiring companies sponsor visa for Python coders from India? If yes, can you name a few?
So some do, but not all do. And obviously it depends on which country, you'd be moving for. In terms of the UK, which is where I'm from, things have changed recently because of Brexit, which I know is only a European thing, but actually it's affected visas for anyone coming to the UK. But it seems to be the standard rule across most countries, at least in Europe, in terms of what I know, is that companies can sponsor visas. They're generally called a skilled person's visa or something like that, where basically technology or software developers is viewed as a skilled profession. So therefore, they can do it. But basically, companies have to apply to be on the list to do it, especially in the UK, and then they have to pay a certain fee to do that as well. And it takes anything between 2 to 6 weeks. It's not the hardest thing in the world, but not all companies do that. In terms of specific companies, off the top of my head, I'm trying to think actually of roles that I'm working for, have worked for recently, that do sponsor visas. It's generally bigger size companies. In the UK, I believe Ocado sponsor visas, Nutmeg, who are a fintech business, and similar ones like that. The really big tech companies almost exclusively do sponsor visas. Amazon's, Google's, those sorts of companies as well. Tends to be the bigger company, the more likely they are to, basically, because of the finances involved, and they have dedicated teams. Again, it's actually similar to the salary and flexible working and those sorts of things as well. Worth highlighting right at the start of the process. Most job listings will mention it. If it's not mentioned, just message whoever's posted that job, whether it's a recruiter, whether it's an internal person in the company, whether it's whoever it is. If you send them a message, they'll be able to tell you straight away, yes or no, whether or not they can. And then I just see Catalina said, how many projects you consider a good portfolio? I wouldn't say there's a hard and fast rule on number of projects. I mean, more would obviously be better, but no one expects people to spend all their time doing projects, because people have other things to do. They have their social lives, their family life, their current jobs and things like that. So it's not as if companies are expecting every evening, every weekend for you to be doing projects, but I'd say a couple, maybe 2 to 3 would be fairly strong. You don't need hundreds. A couple of different ones would be good. So, and they can be pretty simple stuff. For instance, there was a woman that I worked with who she got her first job within Python development off the back of one project. Basically, she was in marketing as a career. She built a project in using Python and Django mainly. It was a flight tracking application. She built it in her free time. It was on her CV. It definitely helped to get her first stage interviews. She then went through the process, did a technical exercise during the process, for a few different companies, and actually ended up with 2 or 3 offers in the end. And obviously accepted one off the back of that. And she's been there for a year or 18 months or so, and is really enjoying it. So, one is fine. 2 or 3 would be great. You don't need to spend every waking hour doing it, though. Seems like that might be everyone's questions. I haven't got the link, the YouTube, sorry, up in front of me. So unless there's one there.
No, there's nothing on YouTube yet, but maybe we can wait 1 or 2 minutes to see, and then we move on to the next topic.
Yeah. Sorry, Joe. Can you include code along projects in your portfolio if they are not your own work, but you have a good understanding of the code? There is a large project that can be as part of my Udemy course. Could I add this to my profile? As a general rule, I'd probably stay away from that sort of thing. I think you ideally want to put stuff that's 100% your work on your portfolio or on your CV initially. That sort of work that you've been involved in is worth raising during the interview process. If you're talking about projects you've worked on and that sort of stuff, probably steer clear of it on your portfolio. That's probably less is more when it comes to it. If you have a couple of things that are, I 100% built this. This is the technologies I used. This is how I did it, and this is what it was. And maybe a link to the GitHub repo or Stack Overflow, or whatever it might be. That's probably better on your profile. If you're a smaller part of it, probably leave it off, but definitely talk about it in the interview process.
And if I can add to this, you can also put your GitHub link, and there you can mention that it's forked from this project and it's part of this Udemy course. So it's not originally my code, but it's been worked on by me. So then you're making sure that you're mentioning that it's not entirely yours, but it's copied.
Yeah, definitely. That's a good point. I think putting GitHub links directly onto your profile is a really good idea. And actually, I even advise that to senior or principal level engineers that I work with. That there's no drawback of putting your GitHub on there. People can follow it when they see your profile and have a look at it. And yeah, as Bhumika said, if you expand a bit on things in your profile, it shows that you understand how platforms and products are built and what your part is within building them. Companies will often ask you, can you speak about a previous project you've done? And if you end up just speaking about what the platform does, that's not the answer they're looking for. They want people to have understanding of what their specific role within that project was. So if you say this is a thing that I was a small part of, but I did this part of the system, it shows you have an understanding of how systems are built and what specific part you can bring. So yeah, definitely, I think link to your GitHub if you have one, or a Stack Overflow, or whatever you use to add repos to, is worth putting on your profile, just a standard, really.
Okay, I think that's all the questions, and we can move. So this was from the recruiter standpoint, and now we move to some of the developers. And I hand the floor to Carolina, who will talk about data engineering. So,
thanks very
Carolina.
Much. Thank you, Rory, and thank you, Mika. So let me share my screen. Whoa. Do you see it now?
Yeah.
Okay, perfect. Okay. So hello, everyone. My name is Carolina Londoño. Currently, I'm a data engineer at PyLadies here in the Netherlands, specifically in Amsterdam. And I'm going to tell you a bit about my journey and also what I've learned, and also how to become a data engineer and what I do in my daily basis. So why data engineering? So as we have seen, we are in the moment of history where we have most access to the information. In this case, is the internet, and the amount of users on the internet have been increasing. Also, the amount of devices increased. We have now Xbox, smart TVs, mobile devices, maybe 1, 2, 3 laptops. So, and also the amount we spend online is increasing. The formats of the data is diversifying. Also, there are new apps, new services, new websites, which leads to an exponential data growth. And it's a challenge to manage all this data because all the companies want to create money out of it, because you want to understand your business and you want to understand your clients, so you can provide a better service and then make a better profit. So that's why we have to consider data engineering and how we manage this data. So this exponential growth, it's a challenge. So it's not as easy because before this, it was just basically nothing. And this time maybe Hadoop came out, and with the growth of data, new and new frameworks of how to deal with this ever-increasing data changes every time. So that's why data engineering is very important, and it's a challenge to keep up with the data growth. So as I mentioned before, all the businesses want to show the value that the data brings. We want to understand the customers. We want to create machine learning models. We want to create reports, and so and so. But before that, we have to have the data ready for that, because if the data is not readily available for people to build these reports or to build these insights, then we're going to be spending most of the time cleaning the data, gathering the data, and all the pre-work that is required before any of these products are needed to be ready. So that's why many data scientists are now data engineers, because before that was their main task in their daily lives, and now they are becoming data engineers. And even data analysts, business analysts, or even software developers that were working on what now it's data engineer. So maybe you have seen that before, maybe 3 years ago, data engineering was not really a career path, but now you have seen this increase in the job market. So what does exactly a data engineer do? So I summarize it in 5 different bullet points. Of course, this varies from company to company, but this is what I've experienced so far. So the first one is create and maintain infrastructure for the data. So that's the physical part. Then after the physical part, you have to think about the logical part, which is how to model the data and represent it in a logical way. And after you've chosen how you're going to represent your data, you want to make sure that it's updated and is refreshed. because maybe you have the data, but if it's 1 month old, it's not going to help you a lot. And also you have to make sure that this data is secured and it has privacy secure for its user. And last but not least, support the data team, because you're going to be working with people. You're not alone, you're not a robot, you're also going to be working with other people. So this is one of the main day-to-day work tasks that I do. So let's discuss the first item of the list, which is the physical part. Create and maintain the infrastructure of the data. And we have 3 different flavors for this. So we have on-premise, which is having our own service in the company. The cloud, which is using cloud services such as Amazon, Google Cloud, or Microsoft Azure, or many other clouds, but these 3 ones are the most popular ones. Or use a hybrid approach, which is a combination of both. So the first flavor, which is the on-premise, is very common for financial or healthcare institutions. And the reason why is because this company, they really care about the data, and also this data is very sensitive, and sometimes they cannot even leave the building. So that's why many companies have even their own servers / data centers in their companies, and they have to worry about, think about different variables, such as making sure that nobody has physical access to this data center, making sure that the temperature of the room is cool enough so the servers don't overheat, so they can keep working properly. They have to think about multiple internet service providers, so we make sure that once one internet service provider is not responding, then the other one takes over. Also, what happens if the electricity goes away? Are we going to have a generator? Are we going to have another provider for our energy? So there are a lot of things to think about, and also the licenses, because mostly you think about perpetual license, needing to even use a database or a specific software. So it's a lot of overhead when you use on-premise, but it's a price many companies pay because they want to think about the safety and the location of its data. So the most common one, and the one that I've seen, is using the cloud. So many companies have chosen the cloud because of the flexibility that it offers, especially when it comes to costs. So let's say you want to use one server for an hour, you pay only for that hour, and you don't have to buy the entire server for perpetually for all your life just to use it. So this is very flexible when it comes to costs, and also to create and deleting resources. And all the physical aspects that we just discussed, such as energy, internet service providers, physical security, we can delegate this to any cloud provider. So we can think about designing our system more than just administrating this physical aspect. Also, these cloud providers, they offer websites, they offer APIs, or they offer command line interfaces to interact with it. And usually they offer solutions out of the box for the most common use cases. For instance, so they have databases are already available for you. They have buckets for you storage, maybe images or any other format of data. They also have a format for you so you can add permissions and security. So they already know a little bit more about their clients and on what they can offer. And the other approach is the hybrid, which is the mix of both. So maybe you can be found in a situation where some of the data might need to be in one space because of security issues, and the other part it's in the cloud, or maybe you're in the middle of a migration because maybe your company decides to move from using their own servers to the cloud, and at some point you're in the middle of somewhere and you have to keep working with both these approaches. So this is the other flavor that you can also find. So when you use your physical servers, either they are on the cloud or physically, you have to think about scaling, because since data is ever growing, you're going to find moments of that the current resources are not going to be enough. So you either have to scale vertically or scale up, which is adding more resources to one machine, either adding more memory or adding more disk, so you can perform a specific computation. which requires more resources, or even you can use scale horizontally or scale out, which is adding another server / another machine. So all these machines work towards the same problem. It depends of which one you choose. And when you use the cloud, you can have the option to scale out elastically, and they can really notice when you are using more or using less, and you can really choose this. So it's a little bit more complicated when you have physical servers, because maybe you need to scale horizontally or vertically, but you actually don't have the resources. So that's one limitation of working with on-premise servers. So after you've chosen, or after your team or your company decides where to go, using either the cloud or using on-premise servers, it's time to go to the logical data. So we need to store the data, and we need to decide how is it going to be stored and how it's also going to be accessed. Give me 1 second. So the most common one is having relational databases. So by relational, it means that the first aspect of it is having data represented on similar to grids or sort of a spreadsheet, and all the fields are going to be represented by a column, and maybe this will be like a sales table, and here will be the amount of price, the item sold, and it would look something like this, and they will have relationships between each other, and they will connect, so you're able to select data in the relational data model. So when you're using when you choose a relational data model, you have two flavors of it. So you have the OLTP, which is online transactional database, and it's very used for apps or web applications, because it is focused on, as the word says, on transactions. So one user makes a purchase, one user makes has his shopping cart, makes a purchase, or makes a registration, and so on and so on and so forth. Whereas with the OLAP, it's focused on analytical. So these databases are going to be focused on retrieving a lot of data, maybe for 1 month, maybe for 1 year. And it's optimized differently, so it can retrieve a lot of data without slowing down. So if you choose an OLTP database to perform analysis, is going to be a little bit slow if you have a lot of data, because it is not optimized for performing analysis. It is optimized for performing transactions. So for instance, if you use Postgres database and your business has started to grow and grow and grow, and the data has been increasing, then you're going to find one point that performing a query that 1 month before it took you 5 seconds is going to be taking you even 5 minutes. So this is something that you really have to think about when you come to choosing and designing your database, and also looking at the behavior of your company, and also how much you are expected to grow, or if you're going to open in new cities, or how many users are you expecting. So this is something you really have to take into consideration when using relational databases. So we are not in an ideal world where we receive CSVs. We also receive many formats of data. So one other very common format of data is the JSON, or JavaScript Object Notation, which is very common for requesting APIs and getting data from APIs. So this is not columnar. Usually it's very nested. Sometimes maybe this column doesn't come. Oh, sorry. Sometimes this column doesn't come. Sometimes it's just a number. Sometimes it's just letter. So it's evolving, and it doesn't have a very well-defined structure. So you have to find a way to deal with that. So one way to deal with this kind of mixed data and a lot of diversity of data is using data lakes. So you can have a lot of more flexibility, but you also have to be very careful of not just allowing people to dump whatever format, whatever data it is. It also comes with a lot of responsibility when you really also have to communicate and negotiate with the data producers, like, okay, you send me data or a document, but please make sure that you send it on a specific format. Or even if you don't have the possibility to negotiate with them, you are the one who are responsible to clean this data, because we have to present data that is ready to the data scientists so they can build products. So these data lakes can hold any kind of data, so documents, columnar data, or JSONs. And another aspect, once you decide either to go for a data warehouse, which is relational, or a data lake, you also have to think about versioning your database. So you can either time travel on a specific point in time because you want to see how the data looked maybe 1 week ago. Also, you want to see how many new tables you added. You want to see what was the version of a specific table, what was the type of a specific field or column in the database. So you want to version your database. And also you will have to make sure that you are GDPR compliant. And this means that any data, any personal identifiable data of your users is anonymized, and any names, email addresses, or anything that is personal, it should be anonymized. So any users that is querying and has access to your data lake or database cannot really see this and put at risk your users' privacy. So once you have chosen either data lake or data warehouse, it is also our responsibility to keep this data fresh. So we have two options of this. You can use a batch, or you can use the streaming. So batch is when you have a specific day, a specific schedule, and a specific hour, or maybe every hour, or maybe every day, or on a weekly basis, to retrieve data of a specific source. These sources could be databases within the same company, because maybe your company has different departments, and these departments, they produce data. So you want to extract maybe all the data produced on a week. Also, maybe let's say you have third parties that you use for services, and you want to see the data they have produced for you. Usually, these third parties are not going to give you a database connection, because you're going to probably have access to many unwanted things. So usually, they provide an API key, so you can retrieve only your data. And another aspect is also, it could be web scraping, extracting data from any website, or last but not least, a file that someone wants to have just to be able to query. So we also have to add that flexibility. And the other way of keeping the data up to date is in a streaming fashion. And this is very common for data that is being sent all the time, and it's very common for sensors, because sensors are always producing data, and maybe ingesting all the data produced in 1 hour can add a lot of overhead. So you ingest it on a streaming fashion. And there are also APIs that its response can be also streamed. So you're always listening to what it produced, and you just ingest it directly to your data warehouse or data lake. And as I already mentioned, besides making sure that you anonymize personal identifiable data, you have to think about the security, but also when it comes to networking, making sure that your data lake or data warehouse is not publicly accessible via the internet. What if someone leaves the laptop open in a cafe, and then someone just wants to log in? And yeah, we don't want that. So we have to make sure that it is secure in different layers, not only in privacy, but also for internet access. And also we have to make sure that we give permissions only to the data that they need, not to all the data lake or all the database. So we want to make sure that they have access to only specific columns or specific tables, because we don't want to compromise and also give them all this power of having this data, because we also want to narrow the use. And if they need that, of course, we can change the permission. But ideally, and it's a good practice to give permissions to the minimum, in a minimum way. And my favorite part is how you support the team. So usually the most common requests are, how can I add new data? Because people all the time want new data, so you have to help them model the data so it's available for them to query and how they're going to ingest this data. Sorry. Also, you want to make sure that the data is correct. So maybe one API version change, one field change of a database connection. Maybe the internet is down or something. So you have to figure out what is wrong, so you are able to fix it and make sure that the data is back in the data lake or data warehouse again. And since data engineering is a very, very new field, and there are always new frameworks, new tools, because we are trying to be better at how we provide this ever-increasing amount of data. So we always investigate new tools to improve the stacks. I'm pretty sure if there are many data engineers here or potential data engineers, this is something that you really have to think about and keep reading and keep yourselves updated. So I'm going to be talking also about the job market. So LinkedIn launched a report in 2020 of the top 15 emerging jobs in the Netherlands, and data engineering was number 7. You can find the report here in this link. And also, if you go to the 2021 data science interview report, they compare many data science related fields interviews, and you can also find it here. And you can see that most of the skills that a data engineer requires are mostly SQL and Python. And this is also compared to what you can expect during your interviews. And data engineer noticed a 40% increase in the interviews compared to the data scientist, which is 20%. So let's say that you decided to become a data engineer and you want to get started. So my personal recommendation is these 2 things. So if the first one would be the infrastructure. It could be either on the cloud or on local development. So you can, can you mute, can the person mute? Okay. So you can use the free tiers or maybe Amazon Web Services or Google Cloud or Microsoft Azure. They provide some credits for free in the beginning, so you can explore and maybe deploy some things. And also you can emulate some of these services, maybe databases, maybe an API with containers. And also in the part of keeping the data up to date, you can start working on how to create an API, what's an API, how to deploy an API, what are the best practices to create an API. And also get familiar of the frameworks in data engineering, which are, I will say these are the 3 most popular ones: Airflow, Kafka, Spark. And of course, the start of the task, which is cleaning the data, because of course we have to make sure that we take on this responsibility from the data scientists. You can also find a more descriptive, more complete roadmap in data engineering. This is a fraction of it. And you can find a link here if you want to start from the very beginning on how to start basic terminating and yields, data structure and algorithm, and so on. So you can see the link here. It's very broad, so you will never be bored. And also, like we mentioned in the previous talk, it's very important that you work on your projects, especially projects that bring together many concepts, not just one, because you will learn how to bring this, all the pieces that you have learned together. And also you're going to deal with your frustration because you're going to find bugs and you're going to have to learn on how to work when you find a blocker, and also find your weakest skill and you work on it. And also remember that things that we have built, we remember more than just watching a course or just do or repeat something that someone has already done. So if you build something from scratch, it's going to be 10 times more valuable if you just repeat something that someone has done, or just repeat or do one course. So you can show off build your portfolio and show the things that you have learned. You can either use GitLab or GitHub. Also, if you are not sure, you can look for the open source projects and have a look on how some code is being written, what are the best practices, or even start contributing, because maybe you need that, you feel a little bit more direction, and you don't want to work on your own. So it's very good to also start with open source and look for the first issues, and get familiar on how to document properly and how to do tests properly, and what are the pain points that open source faces. And another point, and also I want to thank the PyLadies community, because I would have never...
We will all hear it.
Okay. Okay.
Oh, yeah, I think you should be fine now.
All right. So yeah, another point is the community. So I have to thank a lot to the communities, because I've gotten where I am thanks to communities. Before that, I never found the courage to even presenting myself, to even coding, because I came from an academic perspective, and I was one of the 5 women out of 100 persons. So I was shy. And I think something that is very valuable of communities is that it's a safe space for you to make mistakes, to ask questions, to get familiar with people, to find people who also want to learn the same thing as you, to find people who support you, who believe in you. And I think I found that pretty easy in communities. And once someone believes in you, you are able to also believe in yourself, and you dare to even try to code things that you have never coded, to apply for jobs that you have never applied, because you didn't believe in yourself. So that's why I think communities are very important, especially for women. So I know maybe for COVID, everything is online. So I think instead of being sad about it, I think we can use the internet, because this is where we live. Every open source project has their own Slack channel, so you can join there, ask questions, get familiar with it. Also follow people on Twitter. Many developers are there, many recruiters are there, so they can give you tips. Many job posts are there. You can also find articles on how to get started, or maybe a topic that you are interested in, or maybe something that you found a blog. You can find articles in Medium. And last but not least, YouTube. So YouTube, I will say that in terms of data engineering, there are many new YouTubers on this space. I will really recommend Seattle the Data Guy. I really like it. And yeah, I hope to see you online there. So yeah, that's it. I hope you found this interesting. Thank you so much. Feel free to ask me any questions. You can follow me on Twitter, GitHub, LinkedIn. This is my handle for all my social networks. And yeah, that's it.
Thank you so much, Carolina. It was a lovely talk. And we have one question in the chat. Is there a target age group for these jobs?
No, I would say no. I work with people of all the ages, very young, also people reaching retirement age. So I would say no. Don't feel, you don't have to be a certain age for these jobs.
Okay, perfect. That's very encouraging. And yeah, I would also encourage people to join communities, because I was always a very shy speaker, and it was only after I started joining these communities that I had the confidence to present. So just join in, find a mentor, get out there and try something.
Yeah, indeed. Yeah, same for me.
We don't have any questions on YouTube right now, or yeah, if anyone has any questions, feel free to drop them on the chat here. We have one. Maybe you can just read it out loud, because
yeah. Okay. So Sam said, it says that technology tools in data engineering have a very fast turnover rate. Whatever framework you learn today will certainly be obsolete tomorrow. How can you stay up to date? Yes. So 100% yes, agree. But I will say it's not only with data engineering. I will say it's with any technology, because now you learn one thing and the next week is a new framework, it's a new framework. So it's very easy to get frustrated with this, because I also get this. But at some point you just have to keep up with the core and the fundamentals. So I will say I would really recommend you to go to the basics, or maybe how you can write good maintainable code to make sure that everyone understands your code, that you write good code that is good performance. What happens it has a lot of data, how it can maintain itself in time. So I would say have a set of principles, because these principles are going to be, let's say, your Swiss knife. And whatever new tool and your framework that comes out, you're going to be able to use these principles. And yes, this is something that we have to accept. And probably once you join a company, you're going to have a tech stack that you stick to. And maybe in a couple of years or in 1 year, maybe you have to do some research. It's not that you have to, 1 month you have one tool and the next month you are going to have to use one tool. That's not the case. But if you change jobs, then it's going to be the case that you have to learn the new tech stack compared to what you used to work. So it also depends. Okay, I'm gonna read the next question. I was rejected for most of these jobs as I don't have Airflow experience, despite working in Python and SQL for 5 years. So Airflow is a must. They don't care about my data cleaning skills. It depends also where you work, because if I see that you have very good SQL experience and I really need someone with SQL, because at least for myself, I would think that I'm good with Python, but I would say my SQL could be better. But I think it also depends where you apply to that. If they see that, and if they value also your SQL skills and Python skills more than learning Airflow, because learning Airflow could take you a little bit less depending on the task, then I think it's a matter of finding your company. And also, I would say if you really want to learn Airflow, you can go to the documentations, and they even provide a Docker Compose file, so you can have Airflow locally and play around with it. So I would say don't get discouraged. It's a tough skin that we have to develop when you apply to jobs, because there's even a meme for this, like the emotional damage of the of the technical interviews, because you're going to get rejected. But then don't take this rejection as something bad. Take it maybe as feedback. Okay, I didn't learn Airflow, so how am I going to learn it? Are there documentation? Is there someone that can help me? Can I use Docker Compose? Maybe I can do it a little bit myself. And you can also ask in the PyLadies Slack channel where there is a help me channel where you can ask, and I'm pretty sure anybody will be happy to help you. I will be also happy to help you if I had the opportunity. Okay, so Catalina asks, do you know some NPO where I asked for volunteer about data engineering? Can someone help me with what is an NPO?
I think that's non-profit organization, if I understand correctly.
Okay. Personally, I don't know any NPO for volunteering. No, I don't know any. If anyone knows, please shoot. No, I don't know any. But I would say you can find, Google can help us, or Twitter, or the community anywhere. And I think if I cannot help you or answer the question, many of the people in the community on Slack or Twitter, they can reply.
Yeah, I think if you ask this on the PyLadies Slack, someone should definitely be able to point you in the right direction.
Yeah, definitely.
I think if you don't find a not-for-profit organization directly, you could maybe go for a hackathon, or I had another in my head. And usually in hackathon, the government participates. So then if you pick one of the challenges for the government is, then you are, so indirectly it works like an MPO, the government. And I had another idea, but I forgot it. Maybe I add it later.
Okay, so I'm gonna read Priyanka. I'm not sure if it's a question, but I'm gonna read it. I'm learning everything is not a problem, but it's a pity to be rejected for lack of that experience. Yeah, indeed. Yeah, it's a pity. But I will say then be grateful that you didn't get the job in a company like that. Because if they're not willing to teach you or take into account your experience, then I think you dodge a bullet.
I think we have time for one or two questions. So
yeah, okay. In my opinion, I will consider GitHub a CV. In my opinion, but also it depends also in the company that you apply to, because in GitHub you can add a very nice description for yourself, the tools that you have used, the projects that you have worked on, the companies that you have worked on. I've seen amazing GitHub that you can use as a CV, and maybe you can give it a try. What happens if you apply with only your GitHub and see what you find?
then maybe you get the companies that are looking for very good coding skills. I don't know, but yeah, it's something to try.
Yeah, and I think they are hooked immediately with your code, because a CV is usually a file, and you have your GitHub link there, and you're not even sure if the person is going to visit your GitHub. But if they have the link already there, they have access directly to your code, and it's more likely they will see your code. So I will definitely say that, yeah, go for it.
Yeah, and I've had jobs where I have put my GitHub on my CV, and the entire tech interview has ended up about projects from my GitHub. So it's something that's good to add, maybe not as a sole thing, but it's good to have as an add-on. Okay, I think that's all the questions. Thank you so much, Carolina. It was a really good introduction, and also really good to see how to get into the field, because that was a question I had and you answered quite well. So thank you so much.
Okay.
And
Thank you.
Now we have our third speaker, Giel. So Giel, the floor is all yours.
Thanks, Bhumika. Am I audible?
Yeah,
Yep.
Loud and clear.
Okay, so hi everyone. My name is Giel, and as you may have noticed, I'm a bit of an old guy. So I'm going to take a bit more time to introduce myself, so you can get a feel for what an academic career might look like a little bit. So I'm 40 years old. I've seen a few places around the unis in the Netherlands. So first of all, I actually had an education as a psychologist with a specialization in cognitive neuroscience at Maastricht University. And cognitive neuroscience means that I worked with MRI scanners and EEG scanners. And during my education, I chose to specialize. The final year of my education had the opportunity to specialize in a few courses, and I actually chose to specialize in machine learning and robotics projects, which was an option for psychology at the time. When I was finished with my master's, I started a PhD, not in psychology, but I switched to computer science. And I did this PhD at Tilburg University, and I focused on serious games. And this might seem a bit strange, but these games generate a lot of data, and this data has to be processed. And I made games that you could play in order to basically fill out a personality questionnaire just by playing the game. When I was done with my PhD, I was doubting what to do exactly with my career. So I decided to do some research jobs, postdoctoral positions. I did one at Delft Technical University. And this university was doing a project with the Dutch Railways infrastructure company called ProRail. And they had a company to create software in order to train their train traffic controllers to deal with new changes on the railway infrastructure. So I developed a system that in COBOL, which is really, well, it's still up to date, but it's pretty ancient. It's been around since the 1950s and 60s. And I made these simulations where you could make changes and there would be realistic train scheduling, and the train traffic controllers could practice with new situations on the tracks. After that, I did a postdoc at Open University, and I joined the RAGE project. This is a European project in which components were made for serious games. The intention was for these components to be plug and play. So game development companies that did not have budget to make these components and validate these components by themselves could just grab these components from the repository and plug them into their systems. And during this job as well, I also also programmed some stuff that interact with big data systems, mainly Kafka for educational databases. So it was quite interesting. After that, I was done with the postdocs, and I decided I wanted to get more into teaching. So I got a job as a teacher at Fontys Applied University in Eindhoven, where I taught enterprise software engineering and data science as well, because my jobs before that particular job left me with a lot of experience in this field. And then finally, and that is where I ended up and where I still am today, I got a job at the Open University as an assistant professor at the Educational Sciences faculty in the group of Technology Enhanced Learning and Innovation. And that is where I'm still at this time. And it's probably good to know that the Open University is a university that has mainly online courses, or at least for our faculty, it has mainly online courses. And it's also directed at a bit of older people, which I don't mean disrespectfully. I mean working professionals, which are already working in some field and they want to get their master. So they did not get the master before and they come to the Open University, follow courses. And in particular for the faculty where I am working, there are teachers who are trying to get their masters, and they work with, well, a lot of technology in education. Yeah, so I was there again. Now to give you a bit of an image on which languages and systems I work with, and I can't list everything, but so I started out with a really old one, Delphi. Then I worked in C#, which I did a lot in, and I'm still working in right now. COBOL, Java, Go, which is this language by Google, and of course R. And my main language at the moment is Python, although C# is a close second. So of course I work a lot in Jupyter Notebook, but that's not my only IDE, and I pretty much pick and choose my IDE based on the particular task I want to solve, the problem I want to solve, which task I want to do. The second thing I work on very much is Unity, because I'm still in the domain of serious games, because it's a very important domain for educational sciences, because there are a lot of educational games. I also make lots of front-end stuff, or I did over the course of my career. So I'm familiar with these languages, and of course, sometimes I've worked in particular frameworks related to, well, that work well together on the front end in combination with one of the other programming languages. And then finally, a lot of these interesting systems that have been mentioned before that are related to big data and to message queuing and to asynchronous processes. So I've pretty much seen all of them, and I'm still working with I'm still working a lot with Apache Kafka right now because the the Open University has is very dependent on this system. Yeah, what are educational sciences? I think that's an important question for me to answer. So the educational sciences deal with pretty much everything to do with education and teaching. So educational sciences are pretty much based on educational theory, but it's important to know that educational sciences are pretty much a subfield of psychology. It's a mature science now, but lots of psychological processes play a role when you're looking at educational science principles and processes. So to give you a bit of an overview of what is going on in educational sciences, so if you're thinking about constructing educational materials, you run into this type of thing. If you're thinking about doing some sort of assessment on whether someone has achieved a skill or whether someone can perform a certain task, you're dealing with educational theory. If you are doing anything with students and you have to manage your class, then you're also dealing with this. If you're not just looking at one lesson, but if you're looking at lots of lessons, you have to think about how you want to design your course and how you want students to interact with this. And that's also, of course, educational sciences. And then you want these things to go well. And it's probably the most important thing. So this is a very important topic to study in educational sciences. And then what's also quite important, what's more related, a little bit more related to education, to psychology, but it's also very important to educational theory, is the circumstances and attributes of students, because you can imagine people with different levels of intelligence reach different results based on with the same amount of time studying. Or for instance, if you have any sort of personal difference, like something in the domain of autism or any sort of emotional thing going on, that all impacts your studying capacity and your studying performance. It is all important. Now, educational sciences used to be very hands-on, and I think it still is. If you're a teacher, you're still in front of a classroom lots of the time. But educational sciences, the education area is modernizing quite rapidly. And there are a lot of technologies involved these days in this domain. So you probably all know digital learning environments. If you have been in school in the past 10 years at least, there have been digital learning environments, which are these systems that you can access some account on, maybe even some courses. And it's important to know that the Open University it deals pretty much exclusively with students through their digital learning environment. So these systems can become pretty big, and you probably all know them. Now, another form might be the massively open online course, which you may have experienced in your quest to increase your knowledge about data science and Python. You may not have. Many of them are free. A lot of them are not free, and they have a huge dropout rate. And it's very interesting for educational sciences to look into how people use these systems. Now, this, you all know, multimedia. So whenever you run into any sort of multimedia, and whenever this has been developed by some sort of educational trained person, a teacher or a scientist, this has also always been considered through the lens of educational theory and educational science. This one you may not know very well, although it's still quite well known, is the educational games, or the serious games, in which I am active quite a lot. Then something that's up and coming, it's growing quite rapidly. It's the area of virtual reality and augmented reality. And then finally, there's student-teacher support systems. So if you're talking about digital learning environments or any of the other educational technologies, it's important for students to monitor how well their studies are going. And this is important for teachers as well. and these support systems can help in this process. And you can think about things like dashboards or chatbots or things like this that help you study and that help teachers understand what's going on. Now, I want to talk a bit about research at the Open University because that's what I'm mostly involved in. At the Open University, we have 4 groups, 4 areas of study, which we focus our research. The first area is online learning and instruction. And this is related mostly to these digital learning environments, but even more to the massively open online course systems. Then there's the area of social learning. Whenever you're learning, you can do this alone, as you know, or you can also do it in some sort of group, or this might be with other students, but might also be with teachers. And our social learning group is looking into how these processes work and how they can be supported and possibly improved. And then there are conditions for lifelong learning. If you have left school and you are in the workplace, or maybe outside of the workplace, but still outside of school, you might still want to improve your own skill set. And these things go a little bit differently when you're outside of school, because you have to focus yourself, and a lot of factors come into play here. And that is what is being studied by this Conditions for Lifelong Learning group. And then finally, my own group, which is Technology Enhanced Learning and Innovation. And we focus on new technologies that can support education. And you can think about things like learning analytics, but also virtual reality, serious games, and this type of thing. And it's always important to know at university, there are 2 main tasks. There is also always research in which we do analysis. But at university, also a lot of prototypes are being developed. So, and they are being used for research, but a lot of them are also developed in collaboration with companies. And then hopefully these technologies will reach the marketplace and help everyone improve their study results. So now the question is, very interesting story, but where does Python come in? Well, a lot of you might have already heard a few things that you might imagine are related to Python. And now I want to talk a little bit about analysis. So when I talk about analysis in social science, this is broader than just educational science, as you remember. The primary social science that you can, that I know best is psychology. And these psychologists, they do their analysis using classical statistics. And you might have heard of them, things like the t-test, ANOVA, or regression analysis. And then classically speaking, this type of analysis is done, There's another form of statistics that is up and coming that you might also know about. That's the Bayesian statistics, which is a bit of a competitor to classical statistics. And it's very interesting and very robust, and also very suited to the data engineering and machine learning mindset. So it's a very interesting and up-and-coming field. And then finally, there's machine learning, which is extremely new, except in the areas of cognitive psychology, where some of the principles for machine learning have been studied for a long time now. But the actual techniques for machine learning, the algorithms, they are quite new in the social sciences. So social scientists used to do classical statistics with dedicated software packages like SPSS, but that's no longer the norm. For social sciences like psychology, now R is becoming the norm, pretty much. I think it's at least completely surpassed the classical, the old software packages like SPSS and PSPP, and even Stata. R is obviously also very strong in Bayesian statistics. Now, to focus specifically on educational sciences, the situation is a bit different than social sciences because of the large amounts of data that's coming in with these digital learning environments and MOOCs. in order to process this data. We also do classical statistics and Bayesian statistics, but we're also focusing on machine learning more and more, because that's pretty much the only way with which you can deal with these large volumes of data. And as well, some of the earlier speakers said, in a streaming fashion, you have no chance with classical or Bayesian statistics. And this is where Python comes in. Python is now, I would say, based on my experience, about 50-50 competing with R in the fields of classical statistics and Bayesian statistics. And it really depends on which university you're looking at. But for our uni, it's pretty much 50-50, I would say. But for machine learning, Python is winning, at least for the unis that I know. But there are some other interesting benefits in Python that make it very suitable to educational sciences, and that is the integration part. Because if you're doing any sort of analytics or modeling on the large data sets with students, you're also going to want to look at their registration data. Let's say you have a serious game inside of your course, and you have another data source. You're looking at the digital learning environment, the registration data, and the serious game. And this type of integration, particularly if you have to feed back the information as well in the dashboard, is a very nice thing to do in Python. And then finally, I come to prototyping, which is a very, very important part of my job. So yeah, prototyping. So what do I do with prototyping with Python? Well, I do a few things. One of the things I do, and that lots of my colleagues are doing, is learning analytics. As was mentioned by the speakers before, data engineering is an important part of what we're doing. And pretty much, well, I would say most projects at universities are of a prototyping sort of application. Lots of integrations are made and lots of prototypes are made in the combination between Python and learning analytics. Yeah, so this also goes for integration. So if you want any sort of really, really quick system that's easy to maintain, that just has multiple working parts and is pretty complex, then Python is a very interesting candidate. Now, lots of this stuff has to be reported back to students and to teachers, and sometimes to policymakers. So dashboards are very important to know and to be able to make. Now, serious games is also a large area, although these days simulations are also included often in this description. So in order to understand things, it's really a nice way to work with this. And Python has lots of packages that can help you make nice serious games. Another important thing is if you're a student and your teacher is not available, but you still want some sort of information or help, you can have a look at a chatbot, particularly if you have an effective one. And finally, computer vision and speech processing is important. Computer vision helps, in some situations, helps understand the emotions that students are going through when they solve tasks. And speech can help with presentation. And I want to say text analysis is important as well. And we're looking at this in order to see, for instance, sentiment analysis, have a look at sentiment analysis or this kind of thing, in order to see how well stories are constructed when they are produced by students. Yeah, so I'm not sure how much time I have. I hope I still have time left. This is pretty much my last slide. So I want to tell you a bit about the projects that I'm involved in, concrete projects. So my primary project is a learning analytics project. We have a digital learning environment at OU, which has been active since 2015, which is a few years. There have been over 3,300 course runs, and there have been over, well, 310,000 enrollments in these course runs. There have been millions of interactions. And I have to say, based on the jobs I did before, I would not consider this to be big data, which might surprise some of you, but this data set, the data sets that come out of this system are still small enough to process with some conventional software packages. So below or behind the digital learning environment at our uni is a Kafka data lake. There are multiple data sources that flow into this data lake. We work together with the data engineer to both have, via an Elasticsearch plugin, streaming facilities, as well as snapshots of the data for particular years or particular courses, and sometimes the whole database as well. So it's not big data yet. But this is something we have to deal with when we want to get data out of this system. And then we want to give this data back, mainly to teachers in our case, but in many unis, it's also going back to students to get some warning signals. So the goal for us in this project is to model and predict student dropout. We want to look at the interaction students have with our digital learning environment and get an early warning signal when a student is looking like they are at risk of not finishing the course. And we do this by various machine learning algorithms. Now, another important one for me, in which Python is really helpful, is to make RESTful APIs. So I have a lot of apps that produce data, and these apps are rolled out at schools. So there are students somewhere in the country that are playing my games and using my apps, and they are sending data. Somehow I need to have an interface in which this data can get back to me. I like to use Flask and then GUnicorn or some other nice and really easy to set up Python server to get this data. It's usually, once again, not big data, but it's enough data. And I want to make sure it gets to my database safely and securely. So that's for the data drop-off. Something my students are working on and that a colleague of mine is also working on, and in fact, a few colleagues of mine are working on, is text analysis. I mentioned this before. You can do a sentiment analysis to see what people are thinking or feeling, well, at least what they are considering, what their attitudes are when they write a particular thing. And you can look at argument analysis if people at our uni do their end projects for courses. This end project is usually in the form of some sort of essay, and this needs to be well reasoned. So we are looking at our algorithms in order to analyze this type of document. Now, finally, I exclusively do my data analysis in Python. So I do everything in Python, pretty much. I could use R, but because I use Python in so many other tasks and so many other interesting projects, I just decided to do everything in Python, and it's working out quite nicely so far. And finally, as I mentioned before, Open University is a distance learning university with a fairly old population of students. At our faculty, you have mainly teachers who are getting their master, and they are also doing master courses in which they have to develop technological artifacts, which they are going to use on their own students in their own schools. And these projects, well, they can be many different topics. And I've seen pretty much everything pass by. So I know that we are exclusively offering Python as a tool in the courses on our particular faculty. So I know that Python is growing on schools on all levels of education in the Netherlands, and well, that's my concrete experience in this area. So yeah, hopefully that was okay with time. I have no clue, actually.
You're doing good on time.
Well,
We still have time for some questions, and yeah. People drop them in the chat.
I'm not sure where the questions start. Let's have a look.
No, these are all just older comments. So I think.
So do you want me to read them?
No, I think they're just comments regarding the previous talk, so we can just skip those for a bit.
Okay, so go ahead if there are any questions.
maybe is something to start off for someone who's looking to switch to Python, to educational data sciences using Python. What would be a good starting point, or what skills can they start with?
Yeah, so in my experience, a lot of researchers do their own analysis. But one thing, so the interesting thing about educational sciences is that most people come from a more like soft background. So they have the educational science skills and they have the psychology skills, but they don't have the programming skills. For our particular group, we have a very strong technological focus. So what we do quite often is open PhD positions, as you know, Bhumika. And these are sometimes focused on candidates with this particular programming background. And then if you're able to make prototypes, that is really good for a job in academics. The other side is, I think we have almost an entire faculty worth of support staff that build interfaces to the data lake that we have, and that those skills they range very widely, the skills that you need for this. But I think the most important thing is that if you want this type of job, so not the scientist job, but the support staff job, that you can be flexible with your programming skills. So there it would be a benefit to not just have data science skills, but also to have skills, for instance, in the API building part, data modeling part. If you know a bit more about computer architecture, that's a benefit. Oh, it might also be interesting to know the Open University has about 50-50 staff with regards to male-female division. So we're really gender pro
inclusivity.
Inclusivity.
Yeah, and I'm currently doing my PhD under Giel, so that's how we know each other.
I hope it's with my support and not under me.
No, definitely very supportive. So yeah, and it's also for a lot of people who are looking to switch careers and looking to do a certification alongside your job. The Open University has a lot of courses and certifications that you can do alongside a bit of support and mentoring. So
yeah, it might be good. Since I heard from talks before, a lot of focus on getting jobs in data science and with Python. A very important platform to get jobs at universities in the Netherlands is called Academic Transfer. It's a website, academictransfer.com. It doesn't list all job openings in the Netherlands, but I would say at least 95% of the job openings. So if you are considering a career in uni, then for the Netherlands, that is pretty much the place to go.
If anyone has any questions, also feel free to unmute yourself and just speak it out loud or put it in the chat. Maybe we wait for 2-3 minutes, and then if there are no questions, then we just end the session.
Yeah. Okay. So the question is, what about the level of Dutch required? Open University for Open University it depends. This is a university that focuses exclusively on inclusivity. So it wants to be open. There is a mandate for the university to be open as a place of study for all Dutch citizens. So that means that all courses are in Dutch. So if you want to do education, you need to know Dutch. But for postdocs or PhD positions, there is no particular requirement to speak Dutch. It's encouraged, but it's not required. For the other universities in the Netherlands, it depends. Of all the other universities in my career, all of them offered courses in English. So in those cases, there would be no Dutch requirement. With regards to a job at some sort of support position, I don't think there is any requirement to speak Dutch. So salary in Amsterdam.
I also started at the Open University with very basic Dutch, and then I'm picking it up on the job. So yeah, you can still go ahead with it. And
yeah, there is actually a universal, or at least for the Netherlands, universal CAO, collective labor agreement. This just has a table that's updated every year, and that just lists the exact, I think it's gross salaries. So there's no mystery whatsoever. You can just look up the exact salary in this table. I will look it up in a minute if there's no other questions. But the salary range, yeah, that's a good question. I think the software engineers are also on this salary range. Let me just have a quick Google. Oops. Yeah, so this is the salary scale, and it's the same for every uni in the Netherlands. If you're a PhD, Bhumika, you know this better. I think you start in scale 10, right?
I don't exactly remember, but I have the link saved, so I'm also just looking for it right now. Give me a minute and I'll drop it in.
This is
PhD,
for...
I think we have P1, P2, P3 levels, and yeah, I have to look it up as well.
This is just for universities, right? This is if you are working at a university which has this collective agreement on salary.
Well, they all do. There's no difference between unis.
Yeah, I mean,
Yeah.
just like if you compare, the question doesn't specify company or academic, right?
It says uni career versus software engineer. So software engineer, that's, well, I think it's negotiable. So from my experience at Fontis, there was research back then, which is, I think now 3 or 4 years ago, and there were 5,000 software engineering job positions in the Netherlands open. So there's a huge deficiency of software engineers.
I would, 60 to 80,000 is reasonable.
Yeah,
it's a huge range, so stand up for yourself.
Yeah, and don't be afraid to negotiate for your salary. I think it makes a big difference.
Yeah, and it also depends on per company. I think some startups offer a lot more on the higher end. Some go way on the other end of the spectrum. So
if you give them a range, they will always offer you the lower, and they will even go a little bit under that. So, you know, it's a negotiation. Just give more than what you actually
for sure
want.
If you are at that part of the job interview where you're at the negotiating about your salary, then they are wildly interested in you, and you should definitely be enthusiastic about your skills.
Yeah, I think Rory can also add in from his experience of job levels and salary levels, but
yeah, I'd agree with everything there, really. And yeah, as Giel just said, if you're at negotiation stage, then then they do definitely like you, and it is a market where there's not actually a whole load of software developers around at the moment. So the ball is in your court, really. Companies actually have to do more to attract you than you have to do to attract companies these days. So always worth remembering that.
okay. I don't see any more questions, so, and I think it's also a bit late, so thank you so much for giving these sessions and these talks. They were really insightful and really good advice as well for a lot of people in the community. So thank you so much. And for all those who joined and stayed till the end, we hope this can help you in some way. And good luck. Have a great evening and see you at the session next month. And if you have any further questions, feel free to message us on our social media or drop a message to any of the speakers directly. But yeah, be willing to reach out and take a first step. And usually it's the first step that makes the biggest difference. So take that first step. And see you all.
Thank you, everybody. Remember, if you love your job, you'll never have to work a day in your life. So thank you for joining. Have a good evening, everybody. Take care. See you next time.
Thank you all. Bye.
Thanks all. Bye.